Hi, my name is Drake, and today I'm going to talk about how to measure the circumference of the Earth. This method was discovered by a guy named Eratosthenes. He lived around 200 BC. Eratosthenes. And he was from Cyrene in Egypt. I'm sorry, Africa, or it might be Egypt. But around that time, he knew that on a summer solstice, at around local noon, that on the Tropic of Cancer, there was a well that it casted no shadow. There was no shadow, but any other day it casted a shadow. So he knew that on that day, at that time, the sun was directly overhead. And he knew that some distance above, northerly, on Earth, of the Tropic of Cancer, it wasn't like that. So what he figured is that you can measure an angle of a shadow casted by the sun of a stick and do a little bit of basic algebra and calculate the circumference of the Earth. So let me show you a little bit more detail into how he did that. Let me draw the Earth in its orbit around the sun. Here's the sun. Here's the Earth. And at this point, this is near aphelion. This is near the summer solstice. It's at the maximum distance away from the sun, the Earth, at this point. Okay, so if you was to be somewhere in the subtropical regions, somewhere about right there, northerly of the Tropic of Cancer on the summer solstice, at about local noon, and you was to put a stick in the ground, and this would be the stick. It goes, and if you was to have a line, it would go down all the way to the center of the Earth, have the stick level with the ground, on a level ground, on a flat surface, vertical. It would be something like this. And the sun would cause the stick to cast a shadow something like this. And this angle right here is important. If you can measure that angle with like a protractor, back then they didn't have trigonometry. You can use trigonometry to calculate that angle, but back then they could use something like a protractor. And to find this angle, you could find this angle, which is important, which I'm going to show you why it's important in a little bit. This angle and this angle are alternate interior angles, and therefore they're congruent, they're equal. You can also measure this angle right here indirectly by measuring this angle right here, which all these three angles are equal. You can measure this angle by measuring the height of the sun in the sky on a summer solstice at local noon north of the Tropic of Cancer, measuring the height of the sun, the altitude, using something like an astrolabe, and then subtracting that angle from 90 degrees, which is where the zenith meets the horizon. Okay, well, you can use a little equation doing some basic algebra where this is the distance from you to the Tropic of Cancer. Call that DC. And here's the circumference of the Earth. And equating that to, which if you know that this angle is DC and the circumference of the Earth is that. So equating this ratio to this angle, which I'll call alpha, over 360 degrees, and then doing some cross multiplication where you multiply both sides by the product of the denominator, and then do a little bit of rearranging and solving for this variable, which is the circumference of Earth. You can calculate the circumference of the Earth. And there happens to be another method that I'll show in another video that I actually figured out myself. It involves using the North Star to measure your latitude, and some other stuff. But for now, this is how you calculate the circumference of the Earth, doing some basic algebra and simple observations. Until next time, I'm out.